Close your eyes for a moment and imagine a world where the moment a child is born, their future is no longer a mystery. Their height, their eye color, their IQ, their immunity to diseases, their physical abilities, their personality tendencies, all of these are chosen before birth. Not by nature, not by chance, but by design. Now imagine parents sitting in a clinic, scrolling through genetic options the way we scroll through online shopping catalogs today. Do you want high intelligence, enhanced memory, resistance to cancer, faster muscles, stronger bones, a calm temperament, or maybe a child with musical talent? This is not the plot of a sci-fi movie anymore. This is the direction science is heading. And by 2050, the concept of a designed baby may be one of the biggest ethical debates humanity has ever faced. Today we're going to talk about CRISPR, a technology that gives humans the power to edit DNA as easily as editing text on a computer. It allows scientists to cut, modify, replace, or delete parts of our genetic code. And because every trait in a human being comes from genes, from eye color to disease risk to even behavior, CRISPR gives us the ability to rewrite the blueprint of life. Let's go back to the beginning. Before 2012, genetic editing was extremely difficult, slow, expensive, and inaccurate. Then came CRISPR-Cas9, a gene editing tool discovered by scientists Jennifer Doudna and Emmanuel Charpentier, who later won the Nobel Prize. CRISPR allowed scientists to edit DNA with unprecedented precision. Suddenly, we could fix mutations that cause diseases like sickle cell anemia, thalassemia, and certain inherited blindness conditions. The world celebrated. It felt like we finally had the power to erase suffering, but nobody realized what would happen next. The first shock came in 2018 when a Chinese scientist, He Jiankui, secretly edited the genes of twin babies, Lulu and Nana. He used CRISPR to give them resistance to HIV. The world reacted with horror. Governments condemned it. Scientists protested. The researcher was punished. But the truth was out. The world had already crossed the line. Humans had edited the genes of a child, not in a lab, not in a mouse, but in a real human being. And that child would pass that edited gene to future generations. This was the world's first genetically modified human. And even though the world tried to stop it, the door had already been opened. Now, fast forward into the 2030s. CRISPR technology became more accurate. We developed new versions like CRISPR prime editing and base editing, which could change individual DNA letters without cutting the whole strand. Scientists cured genetic diseases in adults. They reversed certain mutations. They even experimented with extending lifespan in animals. Slowly, quietly, the world started accepting that gene editing might be necessary, not for designing babies, but for preventing disease. Then came embryo screening. Parents could see an embryo's genetic risks before implantation. Risks for cancer, Alzheimer's, diabetes, heart disease, and hundreds of other conditions. Some countries allowed editing these high-risk genes, others banned it. But parents everywhere had a growing desire. If you could remove a disease before birth, why wouldn't you? This question became the moral foundation of genetic design. If editing prevents suffering, is it ethical not to edit? Now imagine the world in the 2040s. Genetic editing clinics become more advanced. They no longer just remove dangerous mutations. They begin offering enhancements. A little improved memory here, a little higher muscle efficiency there, better night vision, stronger bones, improved metabolism. And because CRISPR becomes cheap, safe, and reliable, parents with money begin choosing upgrades. They don't call it designing a baby. They call it giving my child the best chance. This is where the world enters dangerous territory because as soon as enhancement becomes possible, inequality becomes genetic. Rich families can afford to remove weaknesses and add strengths. Poor families cannot. What begins as a medical tool becomes a social advantage. In 2050, genetic editing becomes as common as IVF was in the 2020s. Clinics advertise designer traits, improved focus, athletic performance, healthier skin, faster learning curves, reduced aggression, longer lifespan potential. And here's something most people don't realize. Genes don't just shape appearance. They also influence personality, intelligence, empathy, stress tolerance, creativity, and even risk-taking behavior. If you edit these genes, you're not just choosing how a child looks, you're shaping who that child becomes. Imagine parents selecting for stable mood, low anxiety, high confidence, or strong leadership traits. In 2050, this will be possible. And now the question becomes, who gets to decide what kind of people exist in the world? This brings us to the heart of the ethical dilemma. When humans design humans, do we lose the natural diversity that makes us who we are? Do we eliminate traits that we think are weaknesses but are actually essential for creativity, empathy, or compassion? For example, many mental health conditions are linked to creative brilliance. Autism traits are linked to extraordinary focus. ADHD traits are linked to innovation and risk-taking. Anxiety is linked to problem solving. If we eliminate all these traits, will we also eliminate future artists, scientists, and inventors? Now let's talk about the psychological consequences. If a child is genetically designed to be intelligent, who gets the credit for their success? The child or the parent? If a child is designed to be athletic, did they earn their achievements? Will genetically designed kids feel pressure to live up to their engineered traits? Will natural-born kids feel inferior? These questions will shake the foundation of identity itself. Now imagine a world where governments use CRISPR for national advantage. A country might design soldiers with enhanced strength and night vision. Another might design scientists with higher cognitive ability. Another might design citizens with low aggression to reduce crime. And suddenly, the ethics of gene editing are no longer just personal. They become geopolitical. Genetic arms races could begin where countries try to outperform each other by designing improved citizens. At the same time, a black market gene editing industry will rise. People will try illegal enhancements. Rogue clinics will offer risky modifications. And because CRISPR is easy to use, genetic editing could become a household experiment for the irresponsible, the desperate, or the unethical. Now imagine the world in 2050, where we face a new form of inequality, not economic, but biological. The edited and the unedited, the designed and the natural, the enhanced and the baseline humans. Society will have to redefine fairness. If someone is born with perfect genes, should they compete with someone who wasn't? Will sports allow designed athletes? Will schools compare natural intelligence with engineered intelligence? Will job markets prefer genetically optimized individuals? The fear is not just inequality, it is division. A new genetic class system could emerge where society splits into upgraded humans and normal humans. History shows that whenever humans find a difference, discrimination follows. Now imagine discrimination based on genetic design. But here's the deeper truth. CRISPR is not inherently evil. It has saved lives. It has cured diseases. It has given hope to families with devastating genetic disorders. Gene therapy has restored sight, fixed blood disorders, and treated cancers. CRISPR is one of the greatest medical breakthroughs in human history. The real question is not whether we should use CRISPR, but how we should use it. Should it be limited only to curing diseases? Should enhancements be banned? Should there be global rules? Who decides which traits are acceptable? Who decides what is normal? Who decides what is a good human? By 2050, society will face the biggest ethical challenge ever. Are we ready to design the next generation? And what responsibility do we have toward the children who are created through design? Imagine being a CRISPR child. You grow up knowing your genes were chosen. You know your characteristics were selected. You know your life was shaped before you were born. Does that give you freedom, or does it take your freedom away? Does it make you grateful, or does it make you feel like a product? These emotional questions will define childhood in 2050. By the end of this century, CRISPR may eliminate diseases like cystic fibrosis, Huntington's disease, and sickle cell forever. But at the same time, it may bring new problems we cannot predict. Unintended mutations, unexpected side effects, ecological consequences if edited traits spread uncontrollably through the population. Genetic mistakes cannot be undone. Once you change the human gene pool, the change is permanent. So the future will force humanity to walk a tightrope between progress and danger, between curing suffering and playing with nature, between helping children and controlling children, and between improving life and redefining what life is. The final question for the future is not whether CRISPR will create designer babies. The final question is much deeper. When humans gain the power to design humans, will we know where to stop? Because once the technology exists, once the desire grows, and once society begins accepting enhancement, there may be no turning back. And humanity will look at the children of the future, children whose genes were selected, shaped, and engineered, and wonder, is this evolution or is this engineering of the human soul? This is the story of CRISPR kids, a future where babies may not just be born, they may be designed, and the world will have to decide whether this is humanity's greatest achievement or humanity's most dangerous temptation. Thank you so much for watching the video, and also please subscribe the channel for future videos